Okay, let's get started. Reminder, exams tomorrow night, 6:30, same place as last time, same seating location. So make sure you find out, well, at least remind yourself where you're going. And just like last time, if you get lost, look for your TA. If you can't find him or her, look for me. I'll be on the stage to get things going. Okay? And again, remember, we're doing this fund drive for Relay for Life. So any spare change you wish to donate to Relay for Life to help cancer research would be very much appreciated. Okay, so for the review today, I'm going to basically follow along the study guide I put on the course webpage. I got a few problems I've chosen from past exams that illustrate some of the most important things from each of these major topics that you need to know. Okay? The basic differentiation rules, you got to know the power rule, the product rule, and quotient rule. The first problem I want to work out is on quotient rule. It's from one of the old exams, like I said. I forgot which one. All right, so here we got this function, y of x is equal to x squared plus 3x over 2x minus 1. We like to find y prime at minus 1. Remember, whenever you're asked to plug in any number, don't plug in anything until you've taken a derivative. So first thing you got to do here is to find y prime of that function. Then you deal with the minus 1. Do not put the minus 1 in right now. This one we got a quotient. So quotient rule is a very, very obvious step to go. Or if you don't like quotient rule, you could write it as a product. And then you will use product rule and the chain rule to complete this one. But for this problem right here, it's easier to go with the quotient rule. It's more direct. Okay. This one, it's not bad, but it's a little bit less direct than the quotient rule. Okay, so let's use the quotient rule. Y prime of x. Remember, the quotient rule is low d high, derivative of the top, right? 2x plus 3. Low d high minus high. Is that a drill? Okay, I don't think it's an emergency that we have to do anything about. All right, back to this. Where were we? Okay, low d high minus high d low. If there's something going on that we have to do something, that thing will flash and will show a message. The computer next to me will also show a big, huge message. We can't miss it, basically, if there's something that we have to do for an emergency. Okay, so what did I do? Low d high minus high d low, right? Over low squared. Okay, normally we would simplify this, but we're asked to plug in a number. So let's just go ahead and put in a number without simplifying. That simplification really is not necessary for this kind of problem here. We want x to be minus 1. So this will be minus 2 minus 1. That's a minus 3. Minus 1 here, minus 2 plus 1 plus 3. That's a 1. That's a 1. Minus 3. That's a negative 2. 2 here. Downstairs, it's minus 2 minus 1. That's a negative 3. 3 squared is 9, right? Okay, so we end up getting negative 3 plus 4 over 9. So that's 1 over 9. All right, looks like A there. Okay, so you got to know the quotient rule, you got to know the product rule, you got to know the basic derivatives, the derivatives of exponential, logarithmic, that kind of thing. Questions on this one? Okay, good. Okay, so like I said, make sure you also know the product rule, of course the power rule, and all the basic stuff. You got to know a few trig limits. These two are really the same thing. The limit as theta goes to 0 of sine of theta over theta is 1. But if that goes to 1, then the reciprocal is also 1, right? So these two are really the same thing. This one, we're not going to use this one too much. It's good to know, but for the exam, it'll be focused on just this guy right here. Remember, the way this thing works is that as long as these two quantities are the same, the ratio still goes to 1. Same thing when this guy, with this one right here. All right, let me show you one example dealing with that. The limit of secant of x over x times the cotangent of 3x as x goes to 0. Just got to remember the tools available to you, mainly this one right here. Somehow you need to rearrange this so this shows up somewhere. You may have to adjust for the k and all that, but the first thing here is to somehow get sine show up somewhere. Remember, secant is 1 over cosine, right? And cotangent of 3x is 1 over tangent of 3x, which is the same as cosine of 3x over the sine of 3x. Because tangent is sine over cosine. So 1 over tangent or cotangent will give you cosine over sine. So let's put these into here and see what happens. One over cosine means I can bring the cosine downstairs. Cotangent, let's put it upstairs. And it becomes tangent. Okay? Secant is the reciprocal of cosine, so I can bring it down to the denominator, and I put the tangent up. Now I want sines and cosines to show up. Tangent is sine over cosine. So there's a sine of 3x upstairs. Downstairs we have the x, we have the cosine. And then from the tangent, we also have a cosine of 3x. Okay? Let's rearrange this a little bit. These two cosine here, let's move them aside for now. Remember, when x goes to 0, cosine of 0 is a 1, right? Cosine of 0 is 1. So this second quantity here is 1 down here, 1 down here. This whole thing here becomes 1. This is equal to 1, 1, because the limit x goes to 0 of cosine of x is equal to 1, right? 1. It's 1 over 1. That entire thing is irrelevant. All we need to care about is this one right here. I need to make sure these things are the same. I have a 3x here, so that means I want a 3 down here. Therefore, we're going to multiply, rather divide by a 3. Now, but if I did that, I need to balance that out by putting a 3 back in. And then we got this thing here that's really not doing anything. Okay, so now when x goes to 0, this guy goes to a 1. This is already a 1, and that's a 3. And the limit, therefore, is 1 times 3 times 1. In the end, we get a 3. Okay, is that all right? Questions? Good? All right, so you see this kind of problem, get sines and cosine in there, and somehow try to use this thing to solve your limit problem. All right, so we covered that. Next thing, let's talk about the chain rule. Chain rule is a big topic. I have 2 problems here to look at that. This one, we have a trig function involved. We also have chain rule involved. You also need to know the trig value, cosine of something involving a special angle in the end. Expect the same kind of expectation on the exam. You need to know cosine and sine of the special values, and then, of course, the derivatives of trig functions. F of x is cosine of 2x, the whole thing raised to the power of 3. We're looking for f prime of this, derivative of that, at x is equal to pi over 3. Just like the first problem we did, and all of these other things we've been doing, that pi over 3 is the last thing you want to do. Get the derivative and then worry about the x is equal to pi over 3. Here we have something in the form of u to the power of 3, right? Something more than an x to the power of 3. Derivative using the chain rule is 3 times whatever that was, reduce the power by 1, times derivative of this thing. Okay, so there's the basic chain rule there. Nothing to do here. It's already as simple as it gets there. Here we got chain rule one more time. This is cosine of something more than just an x. Okay? Derivative of cosine of u is negative sine of u. Because this is more than just an x to start, we need a chain rule one more time, giving us an extra 2. Okay, so that 2 is coming from chain rule again because the derivative of cosine of something is negative sine of that same thing times derivative of that something, right? Here that something is 2x. And now whether you want to simplify any more is up to you. There's really not much to do. I would multiply the numbers together and that's about it. Minus 6 cosine of 2x to the power of 2 times sine of 2x. Now we deal with the pi over 3. When we put in pi over 3 here, we get cosine of 2 times pi over 3, 2 pi over 3, the whole thing squared times sine of 2 pi over 3. And cosine of 2 pi over 3 is I'm hearing all sorts of answers. What do we get? Shall we vote on that? Negative 1/2. Okay, do we agree with that? How about sine of 2 pi over 3? That's right. Root 3 over 2. All right, so you got to know those things. If you don't, then you'll be doing all this work for this problem here, and then you won't be able to find the right answer, even if everything up to this point is correct. You got to know these values. Okay, so what do we get? We get negative 6 times 1 over 4 times root 3 over 2. So what is this thing? This is negative 6 root 3, 8. We can reduce this by 2, minus 3 root 3, 4. So this guy? Okay, that's chain rule. I have another chain rule problem. Any question on this one, the one we just did? All right, one more chain rule. If h of x is 2 times g of x over 1 plus f of x, calculate h prime of 2 if f of 2 is equal to minus 3, g of 2 is equal to 5, f prime of 2 is equal to 2, and g prime of 2 is equal to 6. Okay, we don't know what f and g are, but we know a little bit about them. We know f at certain location is equal to this. We know its derivative at the same location. We know g and its derivative at a certain x value, 2. First thing we do is we take the derivative of h. We don't know what f and g are, but we assume they are differentiable. So therefore, when we differentiate them, we just get f prime and g prime. Starting with the quotient rule, low, d high. We don't know what g is, but its derivative is g prime, right? So low d high minus high d low, derivative of downstairs. 1 has no derivative. F has a derivative that's equal to f prime. low d high minus high d low over low squared, whole thing squared, right? Okay, now you got h prime of x, tossing the 2, and then all of these will show up. One plus f of 2 times 2g prime of 2 minus 2g of 2 times f prime of 2, all divided by 1 plus f of 2, the whole thing squared. All right, now you're putting these things. This is 1 plus minus 3. 1 minus 3 times 2 times g prime of 2. What's g prime of 2? 6. Minus 2 times g of 2. 2 times g of 2 is 5. So that's a 10. Times f prime of 2, what is it? 2. All divided by 1 plus negative 3, the whole thing squared. Okay, at the end we get, this is a 12 times negative 2, that's minus 24, minus 20, all divided by negative 2 squared, that's a 4, right? So minus 44 over 4, minus 11. All right, so it's another chain rule problem. We don't know f and g, but we know a few things about them. So by applying the chain rule, we use what we know eventually to find the derivative of this function. Questions? Good. All right, big topic, chain rule. Hey, if you don't know the chain rule for this exam, you will be in trouble. So make sure you know chain rule, okay? There's going to be chain rule everywhere. Everywhere. Next, let's talk about implicit differentiation. It describes the step here, but do practice problems. Don't get used to the idea. Implicit differentiation is when we have a function that's implicitly defined. So here, assume that y is defined implicitly as a differentiable function of x by the equation 2x cubed plus x squared minus xy cubed is equal to 2. Find dy dx at 1, 1. Just like any of these problems, this add whatever thing is the last thing you deal with. Get the derivative, then plugging something. Never plugging anything right away. Okay, you know how to do this. You take the derivative on both sides with respect to x. So we take the derivative of 2x cubed plus the derivative of x squared y minus the derivative of xy cubed equal to the derivative of 2. First part is easy. That's just simply 6x squared. For the second part here, this needs a product rule. Because y is obviously a function of x. Y is something to do with an x that we don't know what it is, but we know it contains an x. So this is really product of two functions of x. product rule first times derivative of the second y prime, or dy dx, same thing, right? Y prime, plus the second times the derivative of the first, 2x. Okay, so this is what we got from using the product rule. Again, product rule here, x times y cubed, right? This is also another product rule situation. So one more time, watch the negative sign here. Negative of first, be careful, first times derivative of the second, 3y squared, and then by the chain rule, we got to multiply a y prime. So 3y squared y prime is the derivative of y cubed, because y is implicitly a function of x. First derivative of the second plus second times derivative of the first. That's a 1. Right-hand side derivative of a constant is, of course, it's 0. Okay, again, normally we would simplify this a little bit to solve for y prime. But if you're going to be plugging numbers anyway, there's no reason to really stick with the simplification. Just go ahead and plug in the numbers for x and y. Now we plug in x is equal to 1, y is equal to 1, right? From this thing right here. So this is a 6 plus, that's simply a y prime. That's a 2 plus 2y, rather 1 times 2, that's a 2. Minus, what do we get? We get 1, 3, minus 3y prime, minus 1, equal to 0. So that tells me minus 2y prime minus 7 is equal to 0. So y prime is equal to 7 over 2. Okay, questions? Did I do something wrong? Where? Wait, what's going on? What's going on? Okay, is everything okay here? Okay, now we plug the last step here. Oh, okay, this is a positive 7 here. There we go. That's a positive 6 plus 2 minus 1 is a positive 7. So therefore, now I subtracted and divided by negative. That gives me my 7 over 2. Okay, is that good? Questions? Good? All right, next thing we'll look at is logarithmic differentiation. It is the kind of thing when you got some kind of variable in the exponent. That's normally when this is involved. For a problem like this, that's where log differentiation is used. Okay, our function is x to the power of sine of x. We're looking for the derivative. Let's call that thing y for now. We want to get that sine out of the exponent. Taking the derivative with the variable in the exponent when this base is not an e or a constant is very cumbersome. Let's take the natural log and get that sine out of it. Okay, I take the natural log, and then left side is natural log of y, right-hand side is natural log of x to the power of sine of x. Log allows me to move the sine of x to the front. So right-hand side is equivalent to sine of x times natural log of x. Now we take the derivative on both sides. Derivative of natural log of something is 1 over the same thing. Chain rule applies because y is something more than just an x. So 1 over y, y prime. Right-hand side is a product rule situation. First times derivative of the second plus the second times derivative of the first. We want y prime, so let's multiply y to the right-hand side. Finally, we really know what y is equal to. Y is this thing. So we substitute it out. And there we go. Looks like B. Okay, questions on this one? Good? Good. Now let's look at inverse trig functions. It's really, really important that you remember the domain and range of these inverse trig functions. This is one of the problems we gave last semester. It's a very, very simple problem, but I think close to half of the people didn't get it right. Anyway, let's make sure that doesn't happen this time. We have an inverse sine of something. You got to remember that the inverse sine, we'll call that x, whatever the input is. Inverse sine can only give you an angle that's between minus pi over 2 and positive pi over 2. It has to be in the fourth quadrant or in the first quadrant. Inverse tangent is defined the same way. What about inverse cosine? Who remembers what the range of inverse cosine is? 0 to pi, right. Be very careful with that, 0 to pi. Okay, so here, this is asking for some angle whose sine is equal to negative 3 pi over 2. We know sine is negative in 2 quadrants. It's either in quadrant 3 or quadrant 4. But because we're dealing with an inverse sine here, we are restricted to just quadrant 4, right? So this cannot be it. quadrant 1 or quadrant 4. So even though quadrant 3 angle would also fit the description that has a negative sign, it cannot be the right answer. It's got to be the angle in quadrant 4. So let's see. It cannot be A. A is in quadrant 1. It has a positive sign. It cannot be A, C, or E. Or actually, look at E here. E is the third quadrant angle. E is this guy. You can't choose that one. So you're down to B and D. Okay, so which one? It's not A, right? Not A. It's not C. It's not E because this is in quadrant 3. And both of these are quadrant 4. Therefore, it's which one? B? B? B as in book? All right, good. Okay, like I said, when we gave this exact same problem last semester, about half the people got it wrong. A lot of people chose 5 pi over 3. You got to remember the range of these 3 inverse trig functions. Questions? Okay, the next one I want to do is, let's do this one. It's an exponential growth decay problem. On the first day of Christmas at 8 a.m., my true love gave me 10 grams of a radioactive substance. Ouch. On the fourth day of Christmas, again at 8 a.m., I had 3 grams left. And I'm still alive, apparently. What is the half-life of that substance in days? Okay, so we have 10 grams. Remember, this is an exponential. By the way, don't worry. You're not going to see a Newton's law of cooling problem on the exam. That's just too messy and too complicated. There'll be some sort of basic exponential growth and decay, but no Newton's cooling problem on the exam. Okay, so we got exponential growth and decay, so we're looking at this kind of equation. Y of t is y at the initial time times e to the kt. On the first day, day 0, right? On the first day, I have 10 grams to start. On the fourth day, you got to be really careful with how we count days here. The fourth day is actually 3 days later. On the second day, it's 1 day later, right? So on the third day, it's 2 days later. So even though it says on the fourth day, it really means 3 days after I've started. That gave me a 3. So I start with 10 grams. I wait 3 days later. I have 3 grams left. Now I need to find this, use the information here to find K. Once I have K, I can deal with the half-life. Okay, so if I use this information in that equation, left-hand side is 3. Initial amount is 10. And this took 3 days to decay. So the power is 3 times K. 3 times K. Okay, let's find K. Divided by 10. Take the log. So therefore, K is equal to 1 over 3. Natural log of 3 over 10. or natural log of 3 over 10 to the power of 1 over 3. All right, now I'm going to rewrite this equation using this k and that initial amount. Y of t is equal to 10 e to the k t is the same as e to the ln of 3 over 10 to the power of 1 over 3, that entire thing raised to the power of t. So that's equal to 10 times e to the ln of something is just that something to the power of t. So that's 10 times 3 over 10 to the power of t over 3. Okay, so that equation describes everything that's going to happen at any future time. You give me a t value, I can tell you exactly how much I will have after that much time. Now let's find the half-life. The half-life, remember, is the time for the substance to decay to half of the initial amount. I know that many days later, I'm going to have half what I have started with. Find half-life. Okay, so future amount is 5. Initial amount is 10. So in this case, that t must be representing the half-life. T is how many days I gotta wait for 10 to decay to 5, right? Now we can find that pretty easily. Divided by 10. Take the natural log. Natural log of 1/2 is natural log of 3 over 10 to the power of t over 3. So that's t over 3, ln of 3 over 10 running out of space here. I'll fill this in here. I'm looking for t. So t is equal to 3 times ln of 1/2 divided by ln of 3 over 10. Okay, now we got a problem here. That looks nothing like any of these answers. What do we do? I can tell you it's not E. It's one of these 4 here. It's not 2. Okay, it's not 2. It's not E. It's one of the remaining 3. How do I make this look like one of those remaining 3? Log rules, yeah. Like specifically, how do we do that? Yeah, you're on the right track. So here's one thing you could do. Instead of a 1/2, notice I don't see any 1/2 here. So that means I don't want this 1/2. Let's rewrite the 1/2 as 2 to the minus 1. Downstairs, we could also look at this natural log of 3 over 10. Look at this. I got a natural log of 10 over 3 all over the place. And we know 3 over 10 is 10 over 3's reciprocal. So I could rewrite natural log of 3 over 10 as natural log of 10 over 3 to the power of minus 1. the same way I rewrote natural log of 1/2 as natural log of 2 to the power of -1. Log allows me to move the -1 to the front. Makes that a -3 ln of 2. Downstairs is a negative ln of 10 over 3. And of course, the two negatives cancel. So we end up getting 3 ln of 2 over ln of 10 over 3. And this is really b, because I can move the 3 back here to make it 2 to the power of 3, right? So that's ln of 8 over ln of 10 over 3. Okay, it's got quite a bit of a natural log manipulation here. We're not going to make you do that much natural log manipulation, but you got to know the basic stuff. You got to be able to at least do a little bit of rearrangement to get the answer to at least look like one of the 5. Questions? Okay, a couple of things I didn't get to talk about. Be sure you also look up how to tell when something is speeding up and slowing down, that kind of problem. Remember? You got some particle with some kind of position or velocity. You need to be able to tell when that thing is speeding up, slowing down, that kind of problem. Make sure you review the homework problems and do as many practice problems as you can. But what we did today should give you a pretty good idea of the kind of thing to expect. All right, that's it. See you tomorrow night. So you can, but you